Okay, here we have a function defined through this integral, which is impossible to do, and or very difficult to do anyway. And what we have to do is to try to classify what are the local extrema within the interval 0 infinity, right? So we need to calculate the derivative of this function. And using Leibniz rule, this is the sine of x squared, the exponential of the sine of x squared, multiplied by the derivative of this, which is 2x. Okay? Right, so this equal to 0 determines the point where the possible candidates of this being positive, for this to be local extrema of the function. Okay? Now, this number is always positive, so it's 2. So the equation we have to solve is this one, equal to 0, right? Okay, so we have, of course, x equal to 0 is one root, right? One possibility, but that's out of the interval that we're trying to figure out, so we can ignore this one. And then the rest of them are the points where this is a multiple of pi, where n is any natural number. So that means all the points n equal to the square root of n pi. All right, the square root of n pi. So these are all possibilities, all the candidates to be local extrema of this function, right? Now we have to figure out what is the sign of this derivative between two consecutive zeros of this derivative, right? So this is just, well, as I said, this is positive. For x between 0 and infinity, this is positive 2, right? So it is the sign of this that determines the sign of this, what determines the sign of the derivative, right? Remember, the sign begins being positive, then negative, then positive, then negative, etc. So if you plot here these points, so this is going to be square root pi, the first, the second will be square root 2 pi, then square root 3 pi, square root 4 pi, etc., right? Then between 0 and square root of pi, the sign of function is positive. Then between square root of pi and square root of 2 pi, the function is negative, then positive, then negative, then positive, etc., right? So here the function grows, decreases, grows, decreases, grows, etc. So these are maxima with odd number here, and the other are minima. So every point of the form 2k square root of 2k1 times pi, for k a natural number, right? For k equal to 1, you have 1 here, that's the first. So every of these points are a local maxima of G. And points of the form 2k times pi, where k is a natural number, are local minima of the same function. So that's the classification of all the points of this function.